All right, let's just jump right into this explainer. Today, we're talking about how to completely free your AI from its static training data by building a truly web-connected agent. Because look, if you're building an AI agent today, you already know the golden rule. Your agent is literally only ever as good as its data. We've got a really clear roadmap for this one. We're hitting 6 key areas, starting with the knowledge cutoff problem, why raw scraping fails, the agentic workflow, live search tools, extracting structured data, and we'll wrap up with how to properly feed that context window. Let's get to it. Starting off with Section 1, the knowledge cutoff problem and the real limits of static data. Now, think about modern large language models for a second. They're essentially like a brilliant, genius-level brain, but trapped in a jar, completely cut off from the live world the second their training finishes. And the measurable stakes here, they're huge. We're talking about 35%. That is not just a minor inconvenience, that's a critical failure rate. Yeah, according to recent industry data, when your AI agents lack access to the live internet, they inevitably try to guess the present based on the past. And the result of that guesswork is a massive 35% spike in hallucinations whenever a task requires current info. So whether you're having it check product availability, pull the newest software docs, or verify real-time prices, an agent that relies solely on its static training data is a massive liability. Now, you might be wondering, why don't I just stuff the prompt with a ton of historical background data to compensate? Well, if you try that, you hit a total wall known as context rot. A study by Databricks actually found that model correctness drops off a cliff right around 32,000 tokens. It's this phenomenon called being lost in the middle, where crucial information buried mid-context just gets completely ignored by the overwhelmed model, no matter how relevant it is. Which brings us nicely to Section 2. Why raw web scraping fails, and the core problem with HTML. So the hard truth is, giving your model internet access is definitely not as simple as just dumping raw web pages into it. Traditional web scraping totally fails for AI. Why? Because raw HTML is just absolutely packed with heavy JavaScript bloat, dynamic loading elements, and just a ton of visual noise. AI agents don't want that. They need clean, structured Markdown or JSON to actually function efficiently. If you feed an LLM raw HTML, you are going to burn through your context window instantly with useless tags and tracking scripts. And if you do feed an agent messy web data, its reasoning basically derails in 4 very specific ways. First, you get poisoning. That's where a hallucination or an outdated fact enters the context and just keeps getting repeated. Second is distraction, where the context gets so big the model completely loses focus. Third is confusion, where irrelevant scraped noise starts steering the response. And finally, clash, where different parts of that messy context just straight up contradict each other. Okay, so how do we fix it? Let's get into Section 3, the agentic workflow and autonomous AI actions. To bypass this knowledge cutoff completely, we have to make a fundamental shift from generative AI to agentic AI. Unlike a simple, prompt and response generative system, an agentic workflow gives the AI absolute autonomy to take actions towards its goals. It can use multi-step retrieval, make specific tool calls, and actually run live searches to make decisions based on current reality, not just the static weights from its training. If you look at how a modern retrieval pipeline is structured, you can literally trace exactly how a query goes out to a web search engine and brings back highly relevant documents straight into the system prompt. In this kind of agentic setup, the agent's own decision logic determines which function goes out to retrieve the context. It can search the web, pull the live results, and dynamically synthesize the whole thing on the fly. And to actually orchestrate these autonomous agents, builders are leaning heavily on powerful open-source frameworks, things like Llama Index and LangChain. These tools are absolute game changers. They manage the core data routing, handle the tool calling, and drastically reduce the boilerplate infrastructure so you can just focus entirely on building out that retrieval logic. All right, moving on to Section 4, live web search tools and physically connecting to the web. To actually plug those frameworks into the live internet, we need specialized tools, and the demand for them, it is literally exploding right now. The browser automation market is projected to grow an insane 45% year over year, and this is being driven almost entirely by AI agents taking on autonomous tasks, like checking current inventory for e-commerce, pulling the latest research papers, or automating these complex multi-step workflows across different web pages. So to solve that raw HTML nightmare we talked about earlier, developers are turning to AI-specific data extraction platforms, tools like Firecrawl or Crawl4AI. Just looking at Firecrawl's endpoints, for example, the /scrape endpoint specifically transforms those stubborn JavaScript-heavy pages into clean Markdown or JSON. The /search endpoint returns AI-ready content right from top search results. And then you have endpoints like /crawl and /map, which literally let the agent systematically explore and discover an entire site structure totally autonomously. Next up, Section 5, extracting clean, structured data and formatting it for AI. Once we actually have the data, we have to format it properly so the AI can use it without hitting those context window failures. This means you absolutely have to render dynamic JavaScript flawlessly and format the output into perfectly structured JSON. Advanced workflows are also using techniques like entity disambiguation, which is just a fancy way of saying it consolidates different references to the exact same entity, making sure the data is 100% consistent before it ever even reaches the language model. So if you're building this out, here is your golden path, the reliable 4-step execution for a web-connected agent. First, the agent searches the live web for the query. Second, it scrapes the required pages using those AI-specific tools to render the JavaScript. Third, it extracts and normalizes that messy data into clean JSON or Markdown. And finally, step 4, it passes that fresh, AI-ready data directly into the context window. Which brings us to our final stop, Section 6, context window feeding and managing token limits. You can't just shove all that fresh JSON in there all at once and hope for the best. Because models have really strict token limits, you must efficiently chunk the incoming text. You'll see high-performance libraries like PyMu-PDF2 handling the document conversions, while specific chunking strategies like Sentence Splitter ensure logical, natural sentence detection. Or alternatively, you might use Token Text Splitter to ensure the data chunks are mathematically optimized for your specific model's exact context window. But you really gotta watch out for this next part. Even with perfectly clean data, you might encounter what researchers called the tug-of-war effect. This is wild. It happens when the model's internal, outdated training knowledge actively conflicts with the fresh facts you just scraped. The model might literally try to argue with you. You have to design your system prompts to aggressively prioritize the newly retrieved context so it always wins this tug-of-war. And as a quick aside on the bigger picture here, as these web-connected agents become vastly more capable, infrastructure security is having to level up right alongside them. We see this clearly outlined in the 2026 White House Executive Order 1449. It explicitly prioritizes the cyber defense of federal systems against AI threats. It establishes a new AI cybersecurity clearinghouse, and it introduces a framework for assessing those really advanced covered frontier models before they deploy. The whole ecosystem is basically maturing rapidly to handle these powerful agents safely. So what is the ultimate takeaway from all of this? It's that an agent equipped with live, clean web data transforms from just a cool novelty into a powerful, reliable engine. It graduates from just generating text to actually executing real-world tasks. We're talking completing complex e-commerce purchases, synthesizing days of deep research in minutes, and providing hyper-accurate, real-time customer support. So, with the knowledge cutoff finally bypassed and your AI agent truly plugged into the live internet, what incredible autonomous workflows are you going to build today? Thanks so much for joining me on this explainer, and I honestly can't wait to see what you all create.